We're going to look now at the derivative of exponentials and logarithms that are not base e. So we started out by discussing e to the x, and we said the derivative of that was e to the x, and then we did ln x, and we said the derivative of that was 1 over x. And so now the question is, what happens when you change the base? And we're going to use the derivatives of e to the x and ln x to find the derivatives of b to the x, that is some base that's not e, so 2 or 3 or 5 or whatever, and the general logarithmic function, which is log base something other than e. So the general logarithm that we use fairly regularly is log base 10, but you could use log base 3 or 4 or 5, whatever. So we want to know how we're going to find those derivatives, and we're going to find them by basically switching them into these kind of derivatives. So if we start with b to the x, what we're going to do is basically say that e to the ln b is equal to b. We're going to make that substitution. And if you're wondering why, if I say ln b is equal to something, so let's say y, then that statement written as an exponential means that e to the y is equal to b. And y is ln b, so that's why we can say that e to the ln b is equal to b. All right, and hopefully that helps you understand that. And if it doesn't, then there are other ways to describe it, and I can show you those at some other point, but just for the sake of the time in the video, that's the easiest way of understanding why that statement is true. But so if I do that, I'm going to replace b then with e to the ln b, and the x is still there. Then I'm going to take the derivative. So this is going to be a chain rule now. It's e to the ln b, so the derivative of that is e to the ln bx. And then the derivative of ln bx, that's a constant, so it's ln b times the derivative of x, which is 1. So that's the derivative. And then we just take the e to the ln b and replace it back with b. So we end up with this statement, that the derivative of b to the x is b to the x ln b. So what that means is if I have, for example, y equals 2 to the x, I don't know why this is doing this, try it again here, then the derivative, y prime, is 2 to the x ln 2. If it was 3 to the x, then again, it would be, I don't know why my pen is not functioning as well as I would like. There we go. And 3 to the x ln 3. So whatever the base is, you have to put ln of the base beside it. So that's the exponential derivative. The logarithmic derivative is very similar in terms of what we're going to do. We're going to try to write it as ln. So we're going to change the base. So we're going to start with going b to the y equals x. Okay. Then we're going to take the ln of both sides. Then the rules for exponents say I can bring that y down. So I'm going to do that and solve for y. So y becomes ln x over ln b. If I take the derivative of that, then it's going to be y equals ln b is a constant. So I'm going to write it like this. Okay? Whereas I'm going to write it as this constant, 1 over ln b multiplied by ln x. And so that y prime is going to be 1 over ln b times 1 over x. And if you do that and put it together, you get 1 over x ln b. Okay, and there's a couple different ways to do that. There's the quotient rule, which is right here. If you want to do it with the quotient rule, it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And it reduces down to that. Or there's the way I just showed you. But either way, we end up with this statement, that the derivative of log base b of x is 1 over x ln b. So again, just as an example, if we do a simple example of y equals log x, then y prime is 1 over x ln 10. Okay, so you just add a ln of the base. So do a few examples just to show you how this works. So here's one, log base 10 of 3x plus 1. So the derivative of log base 10x is 1 over 3x plus 1 ln 10. We just have to add that ln 10 in. And then it's times the derivative of 3x plus 1, which is 3. So if you simplify that, it becomes this. All right. 2 to the cosine x. So it's b to the x. It's a base that's not e, so it's 2 to the x ln 2. but it's not x, it's cosine x. So we put the cosine x there, and then we have to do a chain rule. So to multiply by the derivative of cosine x. The derivative of cosine x is negative sine x. Okay, so that's how we use it there. This one is interesting. I just want to make sure you understand the difference between this is a power rule and that's an exponential. And you can see the contrast, hopefully, that here, this is a power rule. We're used to x cubed. We know the derivative of x cubed is 3x squared. What's happening, though, is the variable is in the base. And the exponent, the power, is constant. It's a number. Here, the number is in the base, and the variable is the power. And when that happens, you have to treat that as an exponential. So the derivative of 4 to the x is 4 to the x ln 4. So that's the difference between the power rule and the exponent derivatives, or the exponential derivatives. Okay, and you can get more complicated. So here's one that's a little more complicated. We take the derivative of cosine, then log base 2, and then 3x plus 1. So the derivative of cosine is negative sine. The derivative of log base 2 is 1 over the function, ln 2. Excuse me, multiplied by the derivative of 3x plus 1, which is 3. Okay, so we're just adding that in. And at this point, you are very comfortable with derivatives generally and with the derivative rule. So this is not that much more difficult. It's just remembering to stick that ln 2 in there. All right. And so then you can get things that are a lot more complicated. This is obviously more complicated than anything you'd actually see on a test, but it's something that you should just try to see if you can do it. So I would suggest at this point that you pause the video and just try to find the derivative of this function. And now we'll look at the solution. So here's the solution to that question. And I'm not going to go through the whole thing, but it's the bottom function times the derivative of the top. So the derivative of sine is cosine, then the derivative of ln, then the derivative of what's inside the ln, then it's minus the top, has the derivative of the bottom, which is cosine, and then e to the 4x minus 3. So it's not that any of this is particularly complicated in and of itself. Each particular derivative that we've looked at is really not that hard to remember or not that hard to do. It's getting the combination of them that's more difficult, and therefore it's more difficult to remember everything because you're trying to remember 2 or 3 rules at the same time. Or you're trying to do the quotient rule and a chain rule and and a product rule and all those things all at the same time. And so it's easy to get lost in all the different steps, but that's the concept of the bases that are not E. So I'm going to leave it there. We're going to practice some more of that. Then we're also going to get into implicit differentiation after that, and we'll kind of go on from there. But this is the last of the functions that you have to know the derivative of. So you've done all the polynomial stuff with the power rule. You've done all the trig functions. Now we've done all the exponentials and all the logarithms. And so at this point, you have arrived at a place where you can say, any function, I can take the derivative of it. I can do it. And that's a good place to be.